you of. What does that look like? Amy.
A z-score with the t-test.
It looks like a z-score, right? I mean, like a regular z-score, but it's a z-test, and notice it has sigma. Okay, so those are the formulas that you need to know. Now, when I say need to know, you need to say, hey, that goes with a one sample z-test. Because on your formula sheet, they have all of this information, but you have to know, hey, I use this one, I use which ones I use for which test. So yesterday we did the parameter and we did our null hypothesis. We're going to skip the assumptions, and now we're going to name the test, and then we're going to talk about the alpha level, okay? So you've named your test, you have this information, we're going to put it in there, and then we're going to talk about our alpha level. Your alpha level is your significance level, and at that point, at your significance level, what we're testing isn't just happening by chance. Something is happening to cause this, okay? So there are 3 significant levels that we test, okay? Now, you don't have to test them all at once, but I just want to show you. So we have, that's a significance level, alpha. You can have alpha as 0.01. You can have alpha at 0.05. Or you can have alpha at 0.10. The one that we use the most, okay, is this one. That's the one that if they don't give you a significance level, this is the significance level you use, okay? Now, you guys, if you... And what this means is we're going to get a p-value, okay? Our p-value, we're going to relate our p-value to one of these numbers. If your p-value is really close to this significance level, you can't make a decision, okay? And I need you to write that. So there are 2 conclusions you can make based on your alpha level, okay? So you have your test, you have a significance level, and now you have a conclusion. These are the 2 conclusions that you can make. You can fail to reject the null hypothesis, or you can reject the null hypothesis. You notice what I did not write. I did not say we accept the null hypothesis, we fail to reject it. You guys, when we're doing a significance test, we are doing, that is one part of many tests. So for this particular test, what we are saying is we can fail to reject it or we can reject it. Well, how do you know? How do you know when to fail? No, that didn't come out right, right? How do you know when to fail to reject, or how do you know when to reject? Okay? So, you fail to reject when your p-value is greater than your alpha. and you reject when your p-value is smaller than your alpha. Now, I'm going to tell you, you're going to do this in your calculator. You're going to use your calculator. You're going to find your p-value. You can use your chart, but most of the time you're going to use your calculator. If by chance you're going to tell your calculator whether you want it to be greater than, so I'm going to teach you. So your alternative hypothesis, right? That's what you're going to put into your calculator. And if you put the wrong alternative hypothesis in your calculator, you're going to get a p-value that will be like 99. Your p-value will never be, if you get 0.9999, that is a very, very large p-value, and that you did something wrong. There are some clues that maybe, ooh, did I put the right alternative hypothesis into my calculator? So again, there's 3 things that we've learned. Okay, so we've named the test. So it's good for right now, our test next week, right? You're like, oh gosh. Okay, it's gonna be one of these 3. Okay, which one do you have? You're gonna pick an alpha level. This is the one, so they don't give you an alpha letter, you pick one. This is by far the best alpha level that you can use, but we use this one. This is the general rule of thumb. And then we talked about our conclusion. You have 2 conclusions. You can either fail to reject the null hypothesis or you reject the null hypothesis. Those are the 2 things, okay? Are we good with that?